Hey guys, Chavez here. We're about to get started on this new adventure, Graphical Analysis. I hope you guys are happy. And let's just get right into it. So, yeah, let's just get right into it, guys. We're going to do one outtake and we're going to go straight. We have four free response questions, and whatever happens, happens. So, here we go. So, yeah, disregard the date because it should have been uploaded yesterday and it's the second. So, my bad there, guys. So let's see. Let f be the function defined in the closed interval between -3 and 4. Okay. With f of 0 equals 3. The graph of f prime, the derivative of s, consists of one line segment and a semicircle as shown to the right. Okay. So here we go. There's that question. And it says, on what intervals, if any, is f increasing? Justify your answer. All right, guys. Well, f is increasing whenever f prime is, yeah, you're right, whenever it's positive. So you're positive between -3 and -2. So I'm just going to write a statement here. I'm going to say f is increasing on the interval -3, -2, since f prime is positive on this specific interval. And there it is. You're done, guys. That's full credit. Usually these, notice that it says no calculator. Usually these are going to be with no calculator, guys, because you're just doing graphical analysis. You're looking at a graph or something. Find the x-coordinate of each point of inflection for the graph of f on the open interval -3 to 4. Justify your answer. Okay. Points of inflection happen when the second derivative changes signs. So remember what the second derivative means, guys. That means when you're, well, we don't have the second derivative here. We have f prime. So that means when f prime changes from decreasing to increasing or vice versa. So I'm looking at f prime here, and I notice that at 0, x equals 0, I change from decreasing to increasing. And then I see another one right at 2 that f prime changes from increasing to decreasing. So there it is. So 0 and 2. So I'm going to write f has a point of inflection. We don't know the y value, guys. We just know the x value. So don't say 0, -2, and 2, 0, because that's a y value for f prime. That's your slope at 0, not your y value at 0. F has a point of inflection at x equals 0, and again at x equals 2, since f prime changed from decreasing to increasing at x equals 0, and f prime changed from decreasing to increasing to decreasing at x equals 2. Done. Full credit. Let me read it again. F has a point of inflection at x equals 0 and again at x equals 2. Since f prime changed from decreasing to increasing at 0, and f prime changes from increasing to decreasing at x equals 2. Perfect. You could have said also f prime changes from decreasing to increasing at 0 and vice versa at 2. But I went ahead and just spelled it all out, or wrote it all out. Find an equation for the line tangent to the graph of f at the point 0, 3. Perfect. So I want a tangent line. So anytime you want a tangent line, you need two things. You're right, point and the slope. I already have the point. The point is 0, 3. Excuse me, guys. I had a Dr. Pepper. Sorry. And my slope, well, I can just get it by f prime of 0. So I come up here and I say, oh, okay, f prime of 0 is -2. So there it is. F prime of 0 is -2. So there's my slope. So I'm going to write y minus 3 equals -2 parenthesis x minus 0. You can leave it like that, guys. I wouldn't, because this one's simple enough. This is just -2x. Just move the 3 to the other side. Y equals -2x plus 3. If you are paranoid, leave it like this one in here. It's correct, but both are correct, guys. Find f of -3 and f of 4. Show that work that leads to your answer. Okay, here's the secret to these. Well, it's not a secret, but here's how I do them. I'd like to think of this as position, guys. Find my position at -3, find my position at 4. And I like to think of f prime as velocity. So if I want position at -3, I need a first, well, do I have an initial position? Yes, they give you an initial position right here. So my initial position plus displacement, area under the f prime curve is displacement, will give me my position. So Chavez, what are you trying to say? I'm trying to say this. I'm trying to say, and I'm going to probably, I think I have enough space to do both of them, but if not, I'll just use different colors. My position at -3 is nothing more than the initial position they gave me, f of 0, plus the integral from 0 to -3 of your velocity. And look, there it is. This is like initial position. This is like displacement. So this will give me my position at -3. And I know what you're thinking, Chavez, but -3 is like initial and 0 is like final because -3 is further left. Okay, don't confuse yourself. Final position equals initial position plus displacement. This is, why did I say this is initial? Because that's what was given. And I want to find f of -3. See, so there it is, guys. I hope that didn't confuse anyone. So I'm going to come up and I'm going to say, all right, I need the area of the curve from -3 to 0. So let's see. All right, I just see two triangles. I see this triangle here is larger than this one. And recognize that you're going from 0 to -3. So it's going to be, well, I guess let's do f of 0 first. F of 0 is 3, so I'm going to write 3. Plus, and then I'm going to put this in brackets because I'm going to fix it in a little bit. So if I'm going backwards, whatever is negative is now positive, and whatever is positive is now negative. So I see a triangle right here. And I know what you're thinking. You're probably saying, why can't I just cancel out from -3 to -1 and just do this little trapezoid? You can. I'm just trying to do something that is simpler. So I think this is simpler for you guys, I think. So this is 2, this is 2, and to get area of triangle is base times side divided by 2. So 2 times 2 is 4, 4 divided by 2 is 2. But since that's below, that's -2, but I'm counting backwards, so it's +2. So I'm going to write 2, and then I'm going to go minus because this one's above the x-axis, and I'm counting backwards, so it's going to be negative. So this is 1 times 1. So 1 times 1 is 1, divided by 2 is half. So 2 minus 0.5. And actually, you can leave it like that. Let's not, though. So this is 3, and then plus 1.5. So 3, 4. So 4.5, or let's see, 9 over 2. Or 9 over 2. If I did a mistake, guys, or I did an error, please let me know. I don't see any mistakes. I think this is correct. I'm going to go to the next one, f of 4. So I'm going to say, all right, f of 4 is equal to f of 0 plus integral from 0 to 4, because that's what I want to figure out, of f prime of x. Well, f of 0 was already 3, plus, all right, let's see. This time I'm counting normal from 0 to 4. Oh, okay. Now look at this. So I'm going to have to do this, guys. I see a rectangle right there. And this is what I want. I want just the shaded region. So what I'm going to do is I'm going to find in green everything. And I'm going to subtract. This, right? I'm trying to pick a different color. I'm going to subtract this in black. So hopefully that made sense. And that will give you what you want in blue. So let's see, the rectangle. So I'm going to do this right here, guys, in the top. So this rectangle, let's see, that is, what number was that? Is that a 4? 4 times 2 is 8. So 8. I'm going to subtract this region here in black. That's a semicircle. So I'm going to subtract, let's see, pi. The radius is 2. So 2 squared is 4. So 4 divided by 2. This is my semicircle. So it's going to be 8 minus 2 pi. Now, remember, that's just the area in blue, but is it below the x-axis? It is, so it has to be negative. So negative 8 plus 2 pi. So there it is. So I'm going to come back over here. Negative 8 plus 2 pi. And if you want to leave it like that, you can, guys. It's technically correct. But I'm going to go ahead and finish it. So negative 5 plus 2 pi. I hope I didn't make a mistake. And if I did, well, correct me, guys, because, you know, I'm human and I make mistakes all the time. All right. Hopefully, if you look at the rubric, hopefully we got them right. And if not, well, I'm sure you guys will let me know. All right, let's continue. So on this one, okay, this is from 2009, question 6. So none of them are going to be with calculator. They're all going to be without calculator. Again, I have f prime, and they tell me how f prime is. It says the derivative of the function f is defined for f prime as g of x between negative 4 and 0, and 5e to the negative x over 3 minus 3 between 0 and 4. The graph of the continuous function f prime, shown in the figure above, has x-intercept of negative 2. So this value here is negative 2. And x equals 3 ln 5/3. So this value right there is x equals 3 ln 5/3. The graph of g on negative 4 to 0 is a semicircle. Okay, so they're telling us by definition that this is a semicircle. And f of 0 equals 5. Okay, initial position. It's like initial position. I wouldn't call it that technically. Between negative 4 and 4, find all values of x, which are the graph of f has a point of inflection. Oh, okay, they're making it easy for me, guys. Justify your answer. Just like before, I have a point of inflection when the second derivative changes signs. They don't have the second derivative, I have f prime. So I'm literally just looking for where this graph changes from increasing to decreasing or vice versa. So I see that I change from decreasing to increasing to negative 2, and then I change one more time at 0. And that's it. After that, that's it. So I'm going to write f has a point of inflection at x equals negative 2 and 0, and x equals 0, since f prime changes from decreasing to increasing and vice versa at those specific x values. Perfect. Done. Full credit. If you stopped, f prime changes from decreasing to decreasing and vice versa, it's possible that you might not get the credit, guys, because you got to state where they change. And I'm saying that they change at those specific x values. If you are critical, and I'm like, oh, I don't really like that, you're just saying those specific x values. Well, the only x values that I mentioned is negative 2 and 0. But if you are very critical, you can say them again, and vice versa, at x equals negative 2 and at x equals 0. And there it is, guys. Done. Yay, we're happy here. All right, so now, f of negative 4 and f of 4. This is just like before, guys. We're going to take this just like position at negative 4, and the f prime's like velocity, and I want to find my position at negative 4, and they already give me an initial position, see? So we're going to take it just like that. And again, if it doesn't fit, I'll use two different colors. So I'm going to write f of negative 4 is equal to f of, what graph did they give me, or what point? 0. F of 0 plus the displacement from 0, that lower limit is always whatever that value is there, from 0 all the way to negative 4. So I'm going backwards there, of f of prime x dx. All right, equals, so f of 0 was 5. So 5 plus, now let's see. What do I got here? 0, 1, 2, 3, 4. Again, that situation just like before. What you really want, guys, is this in red. That's what you really want. So this is just, it looks just like the other one exactly, guys. I'm going to subtract, I'm going to find the area of the rectangle, and then I'm going to subtract that semicircle. So let's see. Area of the rectangle, is it 4 times 2 again? 1, 2, 1, 2, 3, 4. It looks like it is. So 4 times 2 is 8 minus, now I'm going to do that semicircle. So let's see. That semicircle has a radius pi times 2 squared. So 4 divided by 2. So 8 minus 2 pi. So I think it's the exact same semicircle, right? And okay, anyways, so 8 minus 2 pi. Now, am I counting backwards? Let's see, 0 to negative 4. I am. So because I'm counting backwards, this has to be a negative and that has to be a positive because I'm counting backwards, guys. So let's see. So integral from 0 to negative 4 of f of prime of x dx is going to be equal to a negative 8 plus 2 pi. So I come back over and come back to red, and I'm going to write negative 8 plus 2 pi. And it looks like it's the same answer as last time by coincidence, right? So negative 3 plus 2 pi. Let me check if it's by coincidence. Nope. Okay, last time we had something else. But yeah. Last time we had 8 in the front, or 3 in the front. This time it's 5. But anyway, let's just continue. 5 minus 8, so I think we did everything correct. Negative 3 plus 2 pi, so there it is. Oh, yeah, everything's correct there. Now let's do f of 4. So I'm going to do f of 4 in blue. F of 4 is equal to f of 0 plus the integral from 0 to 4 of f prime of x dx, which equals 5 plus, and let's see. Oh, okay. This time they are checking to see if you know how to do antiderivative. All right, that's cool. I'm cool with that. 5 plus integral 0 to 4 of 5e to the negative x over 3 minus 3 dx. Okay, I am just focusing on this part right here. So I hope that it fits. Let's see, 5. That's that 5 from here, from the initial, plus, and I'm going to put up a bracket. So antiderivative, I'm going to write the e first, e to the negative x over 3. And I still have a 5 right here, but before I write the 5, the antiderivative of e to the negative x over 3, if I would have taken the derivative, I would have had a negative 1/3 e to the negative x over 3. But I don't have a negative 1/3 because I'm doing antiderivative, so I got to do the reciprocal of 1/3, which is negative 3. So 5 times negative 3 is negative 15. So negative 15. And then minus 3x. That's the antiderivative of 3, guys. And I'm doing that from 0 to 4. So you do have to pay attention to that 0. Let's see. 5 plus, I'm going to put the bracket. I'm going to do the first one here, open parenthesis. If I plug in a 4, I get negative 15 e to the negative 4/3 minus 3 times 4 is 12. Close, minus, open parenthesis. If I plug in the 0, e to the 0 is 0. So I just get negative 15 minus 0. So I'm just going to put minus 0. And I'm not even going to bother, guys, to fix it. I'm going to leave it like that. And there it is. I'm assuming it's correct. Check the rubric. The rubric will probably have it simplified. I'm going to leave it like that, guys. All right. Between negative 4 and 4, find the value of x at which f has an absolute maximum value to justify your answer. All right, let's see if this one's a good choice for a candidate's test. They said f. Okay. I'm not going to do a candidate's test, guys, on this. Let me tell you why. This one, oh, I didn't want to erase that number. This one, in the entire f prime, there is only one location where the derivative is going from positive to negative. They said maximum. Did I read that right or no? It's an absolute maximum. They said maximum. There is only one location in this whole f prime where f prime is changing from positive to negative. And that happens here, which is this value. So that's what I'm going to state for full credit. My interval is between negative 4 and 4. And I'm going to say in the entire interval, this is the only time that it changes from positive to negative. So I'm going to state that. So I'm going to go 4, negative 4 less than or equal to x less than or equal to 4, comma. There is only one x value for which f prime is changing from positive to negative. Okay, 4, negative 4 to 4, there is only one x value for which f prime is changing from positive to negative. This value occurs only at x equals, and I already forgot it, 3 ln 5/3. 3 ln 5/3. So maybe I put an entire interval. No, I already said it here. For negative 4 to 4, there is only one x value for which f prime is changing from positive to negative. This value occurs only at x equals 3 ln 5/3, comma, hence, comma, absolute max at x equals 3 ln 5/3. And there it is. That's full credit, guys. You probably could have used more math symbols. You know, f prime is positive between here and here. F prime is negative between here and here. That's the only time it happens. Hence, x equals whatever, blah, blah. I like mine better, though. And there it is, guys. All right. Let's keep marching along. We've done 2. We can do 3. Let's hopefully you still have the energy, guys. Excuse me. All right. This is from 2005, question 4. No calculator as always. So what do we have? F prime, and f double prime. And it looks like we have just negative positives and the values for f and a few values for f prime and f double prime here and there. Okay, it looks like we're good. Let f be the function that is continuous on the interval 0 to 4. Notice a 4 doesn't have a bracket. Okay. The function f is twice differentiable except that x equals 2. The function f and its derivative have the properties indicated in the table above, where DNA indicates the derivative of f does not exist at x equals 2. Okay. But I am continuous at 2, though. It says that right there. You're twice differentiable, except that x equals 2. But you're continuous on the whole interval. Between 0 and 4, find all values at x at which f prime has a relative extrema. So relative extrema is just a fancy word for max or min. Determine whether f has a relative max or relative min at each of these values. Justify your answer. Okay, between 0 and 4, you're not looking at 0 and at 4. You're just looking at all the values in between. You're seeing where f prime changes from positive to negative or vice versa. So let's see. I'm looking here. So between 0 and 1, it's positive. And then I'm at 0, and then I go back to positive. So x equals 1 is not an extrema. And then from 1 to 2, f prime is positive. Then at 2 does not exist. And then between 2 and 3 is negative. So 2 is one of them. And then at 3, it's negative 3, negative to negative. Nope, that's it. So just x equals 2. So I'm going to say it goes from positive to negative. X equals 2 is a relative max since f prime changes from positive to negative at x equals 2. And that's it. It's the only relative extrema. I'm going to say x equals 2 is the only relative extremum. Extremum. You probably don't have to say that, guys. I think you're fine right there. X equals 2 is the relative max, and f prime changes from positive to negative at 2, and you're done. Okay. On the axis provided, sketch the graph of a function that has all the characteristics of f. The first thing you're going to do, plot your f points, guys. Just plot your f points. So let's see, 0, negative 1. So let's plot that. 0, negative 1 points. 1, 0. So 1, 0 point. 2, 2. 2, 1, 2. 2, 2 point. And then finally 3, 0. 1, 2, 1, 2, 3. 3, 0. And they don't give me a point at 4. It's not continuous anyways, so maybe you write a hole when you get to 4. All right, let's see what they want. There's only 4 types of graph, guys. You're either increasing concave up, increasing concave down, decreasing concave up, decreasing concave down. That's it. That's it. The only way you're going to go from x equals 0 to x equals 1 is to go up. Now, are you going to go concave up or concave down? So let's see. So between 0 and 1, it says f prime is positive. Well, yeah, I'm increasing. But f prime is negative, so concave down. So here it is, concave down. Let's do a little better than that. Concave down. All right. Now at 1, I have a horizontal tangent, so I'm going to try to make it as flat as I can. It looks pretty flat already. Okay. And then between 1 and 2, I'm increasing again, but positive. So my f prime is positive and f prime is positive. So that means concave up. So that's pretty easy to do. There it is. And concave up. It should look, I don't want that to look like a cusp, guys. I want it to look like it's flattened right there. Let me see if I can make, sorry, I'm not a perfectionist. I really am not. But there we go. Okay, I think that's better. All right. Notice it says that my derivative does not exist and my second derivative does not exist. So that means I'm having abrupt changes. So now between 2 and 3, it's negative and concave down. So an abrupt change, so a cusp or a corner, negative and concave down. Boom, there it is. Negative, concave down. And let's see, right at 3. Okay, so I have a slope of negative 3. So try not to make it look like a vertical tangent there. All right, and then negative and concave up. And so here we go. So that should be a point of inflection. So yeah, concave down, concave up. And it doesn't tell me anything about the 4 value. So as long as I'm decreasing with concave up, I'm good. Decreasing, concave up, and then open hole. And there it is, guys. Done. That was actually kind of fun, a little bit. Hopefully that made sense to you guys. Please rewind it if you need it. All right, here we go. Let g be the function defined by g of x equals the integral from 1 to x of f of t dt on the open interval 0 to 4. Between 0 and 4, find all values of x at which g has a relative extremum. Determine whether g has a relative max or relative min at each of these values. Justify your answer. Okay, I have to read it again. Sorry. Let g be the function defined by blah. Between this 0 and 4. Okay, fine. Find all values of x for g has a relative extremum, so max or min. Determine whether g has a max or a min at each of these values. Okay. Let's do this first. Determine whether g has relative. Find all values for which g has a relative max or min. So remember that g has a relative max or min whenever g prime changes signs. I need g prime to go from positive to negative. That means that g has a max. Or g prime to go from negative to positive. That means g has a min. So how do I do that? Fundamental theorem of calculus. Do I have a variable on the top? You do. Do you have a constant on the bottom of the lower limit? You do. So that means g prime equals f. You can say g prime of x equals f of x. That's fine. But I like this one better for me. But you don't have to go that route. All right. So next. Sorry guys, I just got a text from my department here. Let me make sure that if nothing crazy. Nope. Okay. All right. Next. So g prime equals f. So that means I'm going to look between 0 and 4. I'm going to look at f specifically, and I'm going to see where f is changing from positive to negative. So I come back, and I'm just looking at f, just this one. Negative, 0, positive, 2, positive, 0, negative. It changes twice. Negative, positive. It changes at x equals 1. And then positive, positive, negative. And it changes at x equals 3. So there it is. So I'm going to write, let's see, x equals 1 and x equals 3. And then I'm going to say what each one is. X equals 1 is, let's see, x equals 1 is positive, negative to positive. So I'm going to write g has a min at x equals 1 since g prime, which equals f, is changing from, and put a bullet there, from negative to positive at x equals 1. Done. That's it. You got full credit. Well, not yet. Now let's talk about 3. G has a max at x equals 3 since g prime, which equals f, is changing from positive to negative at x equals 3. And let me make sure that that is a true statement. X equals 3, positive to negative. Yep. All right, we're good there, guys. Let's continue. And did I miss anything? I think that's it. Yeah, you're good. All right. For the function g defined in part C, find all values x between 0 and 4, which the graph of g has a point of inflection. Oh, okay, perfect. We can continue along here. So g prime prime equals f prime. So I need to check whenever this graph, the f prime, changes signs. So because that's g prime prime. When that changes signs, that means g has a point of inflection. So let's see. Let's look at f prime. I'm looking at this one, and it looks like just at 2, and that's it. Just at 2 it looks like. positive to positive, did not exist, negative, so positive to negative, so just at x equals 2. So I'm going to write G has a point, Uber Eats, of inflection at x equals, was it 2, guys? G prime prime equals f prime, yeah, positive to negative. At x equals 2, since G prime prime, which equals f prime, changes from positive to negative at x equals 2. All right, perfect. I think that's full credit, and let's keep going. Last one. Don't worry, guys. I hope that you made it through. Hopefully you did it all in one sitting, and if not, maybe you did it in 2 or 3. But as long as we get it done, right? That's the good fight. So I have another graph here. Notice they're all f prime. All of them, none of them you haven't used the calculator for any of them. They're testing our skills, if we can anti-differentiate, if we can do FTOC, if we can do all that good stuff. All right, here we go. They give me the areas between the x-axis and the curve, and it looks like they give me, well, let's see what else they give me. The figure above shows a graph of f prime, the derivative of a twice differentiable function f, on the closed interval 0 to 8. The graph of f prime has a horizontal tangent at x equals 1. Okay, horizontal tangent. X equals 3. And x equals 5. Okay, I can see that. That's where f prime has horizontal tangents. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. Okay, so there's the areas. The function f is defined for all real numbers and satisfies, okay, I always label this initial. And maybe this is not technical, but I always label it like initial in case they're going to ask me. I believe they're going to ask me what's like f of something. Find all values x on the open interval 0 to 8. So I'm not looking at my endpoint, for which the function f has a local min. Oh, interesting that they said local min on this one, because I already understand this one pretty well, guys. This is f prime. I'm already warmed up, so I'm sorry, guys. This is f prime, and they want me to find a local min, and I only see this changing from negative to positive once, but it's not my absolute min. Do they ask me for absolute anywhere in here? Look at that, the very next one. Oh, man, these guys are so tricksters. I love it. All right, here we go. On the open interval 0 to 8, I only see that my derivative changes from negative to positive once. It happens at this value. What value is that? 1, 2, 3, 4, 5, 6. Just at x equals 6. So I'm going to say local min. Oh, f has a local min. F has a local min at x equals 6. At x equals 6. Since f prime is changing from negative to positive at x equals 6. Full credit. Now, I love this question here. Determine the absolute minimum value of f on the closed interval 0 to 8. Justify your answer. Now, on the last one, I did say there was only one time where the derivative was going from positive to negative, so that was an absolute max on that closed interval. On this one, you're right. It's only changing one time from negative to positive, but the difference is it wants an absolute minimum, and this value here at 6 is not the smallest value on the whole shebang. That actually happens at 0. And if you're thinking about it, you're like, Chavez, you're going crazy. Like, no, I'm not going crazy, guys. Think about it. The graph of f, going up, 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 horizontal tangent for a moment, going up, 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 and then at I have another horizontal tangent for a moment, then I go down, go down, go down, go down, go down, but it's just for a little bit, and then I go up, go up, go up, go up, go up, go up. So see, I only went down 3 units as opposed to going up 6, 7, 8. From the 0, I went up 8 times, 6, 7, 8, and then I went down 3, and then I went up another 7. So you can see by that logic that the absolute min happens at 0. So this is a good one for the candidates test, guys. I would just do this. I would say x, and then I would say f of x, and then I would just write my candidates. So it happens either at the endpoint 0. I would not put anything for 1 because 1's not a max or a min. 1, 2, 3, 4. Even though 4 is not a min, guys, I would put it in there as a candidate, and then I would put an A, and then I would put Y. This is a max. a local max. Because they don't want that one, right? So 0, 1, 2, 3, 4, 5, 6. So 6 might be 1. And then finally, the other endpoint, the 8. And of course, the 8 is another max. So that's not a... well, we know this one. This one was given to us. Where are you? Right there. F of 8 is 4. So f of 8 is 4. But this is a max. It might be absolute max. It might be global. I think the 4 might be... Let me see. Went up 8, went down 3, then went up 7. So I think the 4 is absolute, but that's fine. The only candidates are the 0 and the 6. So let's see. I'm going to go here on the side, and I'm going to say f of 6 is equal to f of 8 plus the integral from 8 to 6 of f prime. And they already give me that. So let's see. F of 8 was 4 plus, and then from 8 to 6, 6, 7, 8. This is 8. The area was 7, so I'm going to subtract 7 because I'm going backwards, 8 to 6. See? So I'm going to go plus a negative 7. So 4, 7, 4, 5, 6, 7, negative 3. So this value is negative 3. All right, now let's do, I'm going to put it in blue, guys, so we can see this one at 0. F of 0 is equal to f of 8 plus integral from 8 to 0 of f prime of x dx. If you don't like the negative there, guys, you can always put a minus here and change the lower limit to a 0 and the upper limit to an 8 if you don't like that. F of 8 is 4 plus, and obviously, let's see, I'm going to count backwards, so it's going to be negative 7 plus 3 minus 6 minus 2. So let's see what that is. Negative 7 plus 3, that's negative 4, right? And then negative 4 minus 6 is negative 10, and then negative 12. So 4 plus negative 12 is a negative 10. So let me make sure that I did everything correct here, guys. All right, negative 7 plus negative 3, that's negative 4. Negative 4 minus 6, negative 10. Negative 10 minus 2. Negative 12, negative 12 plus 4. Wait, did I do that right? Negative 7 plus 3, that's negative 4. Negative 4 minus 6 is negative 10. Negative 10 minus 2 is negative 12. Negative 12 plus 4, nope, it's not negative 10. It's negative 8. All right, let me check one more time because, man, I make so many mistakes. 1, 2, 3, negative 4. Negative 4 minus 6, negative 10. Negative 10 minus 2, negative 12. Negative 12 plus 4 is negative 8. Okay, there it is. So I want to know the absolute minimum. There it is. Determine the absolute minimum value of f in the closed interval. So I'm going to say, they want the value. So I'm going to say absolute min at x equals 0, value of negative 8. Or maybe you just say absolute min value of f on the interval is negative 8. I think the table is enough. I think if you circle 0, negative 8, you're good. So yeah, let's continue. What open interval contains 0 to 8 is the graph of f both concave down and increasing. All right, I have f prime. So let's talk about f prime specifically. F is concave down when f prime is decreasing. Because f prime decreasing means f prime prime is negative. And then f is increasing whenever f prime is positive. Does that make sense, guys? So let's slow down. Where is f concave down? F is concave down when the second derivative of f is negative. But I don't have the second derivative. I have f prime. So that means where f prime is decreasing. When is f increasing? Well, f is increasing whenever f prime is positive, because that means I have positive slopes. So I'm going to look for f prime decreasing and f prime positive. So let's see, f prime decreasing and f prime positive. So this interval right here, decreasing and positive. And then again, decreasing and positive. And it looks like that's it, just those two. So 0 to 1 and 3 to 4. All right, so I'm going to write f is both concave down and decreasing on intervals 0 to 1 and 0 to 1 and 3 to 4, since f prime is decreasing and positive on these specific intervals. Boom. Correct. All right. Full credit. Let's go to the next one. The function g is defined by g of x equals f of x to the third power. If f of 3 equals negative 5/2, find the slope of the line tangent to the graph of g at x equals 3. They just want you to find the slope. That's it. They don't want you to find a tangent line. They just want you to find the slope of the tangent line. So it looks like to me they're just checking to see if you know chain rule. So here we go. It wants the slope of g at 3. So g prime of x is equal to, bring the 3 to the front, 3, leave the inside alone, f of x squared times, then chain rule, the derivative of f prime of x. All right. Now I'm going to plug in. G prime of 3 is equal to 3 f of 3 squared times f prime of 3. I have the f prime graph. This is what I have. So I'm going to come up and I'm going to look for f prime of 3. So 1, 2, 3. F prime of 3 is 4. So I'm going to put that somewhere. I'm going to put that somewhere here on the side. F prime of 3 is 4. Now, do I have f of 3? That's the question. Nope, but I can get it. I can get f of 3. All right, let's get f of 3. So f of 3 is equal to f of 8 plus the integral from 8 to 3 of f prime of x dx. Oh, what am I doing? Guys, why come you didn't tell me that we had f of 3? I was already, here I was about to do it, and they give it to you right here. Oh, man, that is so bad. Chavez, come on. Man, I can't believe I did that. Life is awesome. Negative 5 over 2, close it, squared, times f prime of 3. As you can see, I make mistakes all the time, guys. Let's see, 3 times, if I square this, that's going to be 25 over 4. I know what you're thinking. You're like, Chavez, how come last time you just left it alone? Well, I'm confident that I can do this calculation. No, I'm not saying that I don't think I could do the other one. I'm just saying that I think this one's pretty easy to do. The 4's cancels out. 3 times 25 is 75, so there it is, 75. There's your answer. If you want to write a statement, you can. You can say the tangent slope of g at x equals 3 is 75. But I think this is full credit right there. All right, guys. Hopefully you enjoyed our little journey there. I hope you liked it. Give it a thumbs up, please. And yeah, have a good one, guys. Later. Bye.